Very good. Hello, welcome to Data Science with EJD. This is the 60th video in this data science playlist. And interestingly, when I started out, I did not know how far it's going to go. I mean, it's been such an exciting journey. So we got to machine learning and we've been stuck there all this while. I think machine learning has taken at least 50 videos out of all in fact, more than that, maybe 55 videos out of the 60. And it's been a nice one for sure because learning about the different branches of machine learning, like supervised learning, where we talk about label data, and unsupervised learning, where we work with unlabeled data. And now I'm talking about reinforcement learning, where you have an agent in an environment in a particular state with certain available actions that lead to rewards, and then you have a reinforcement of the actions that give the best rewards, right? So this video serves like a kind of capstone project for reinforcement learning. So here we are training and monitoring a proximal. Oh, I think I've been calling this primal a lot. I think it's proximal policy optimization PPO agent on a custom maze using TensorBoard and Dash. So Dash, of course, for dashboard. Yeah. So the objective is to train and monitor a proximal policy optimization agent on a custom maze environment with full integration of reward shaping, TensorBoard logging, Optuna-based hyperparameter tuning, and a real-time dashboard using Dash. So the overview, we have different stages. In stage one, we talk about the custom environment. That's the gym environment now for reinforcement learning as provided by OpenAI. And then the purpose of that is to define problem space, like the maze, the agents, and the possible actions. So it's more like you're setting the tone for the reinforcement learning activity. And you have reward shaping, the purpose of that is to guide learning with informative signals. Then you have PPO training, SB3. Here we learn optimal policy. I mean, the agent learns optimal policy. And then we have hyperparameter tuning using Optuna, and that helps to improve performance. Then you have TensorBoard logging, which helps to monitor metrics during training, and you have real-time dashboard, which will visualize metrics live, and evaluation on held-out mazes, which help to assess generalization, and then you have scaling tips for speed, parallelism, and curriculum learning. Let's go on to implement a custom maze environment in Gym. You have the environment design. Um, so you have the state, which is the observation space, right? So you have option one, you can have a 2D grid with binary or multi-channel representation, e.g., separate channels for walls, agent, and goal. And option two, you can have coordinate-based inputs such as XY position of the agent, right? So, and then apart from the state, you have the action space, which is discrete for in this case, so which represent the four movement directions. A movement, there can be a movement up, that's zero. There can be a movement down, that is one. Movement left is two, movement right is three. And the goal here is that the agent must navigate through the maze to reach the designated goal cell while avoiding walls and invalid moves. So if you remember some of the videos we've done in the past, I actually showed a grid where you have the starting point at the northwest corner, I believe, yeah, the northwest corner, and then you have the terminal point at the right at the I think southeast corner, something like that. So, and then those are like, so once the agent gets into those places, those are terminal positions, right? Then before then they can move up, left, right, and so on and so forth. So we have the gym environment code right here, which we can run. Okay, let me put the line numbers for easier referencing. So to set the environment, the first step, like we said, we have the gym environment code. Of course, we have to import gym. From gym, we then import spaces and import numpy for some calculations. Then we use object-oriented programming where we define a class. So we have maze environment, gym.environment, metadata is render.mode human, and then you initialize, using Python functions. So you reset, you get I think observations, then you define steps and things like that. And by the time all of that is done, you just run that, and then that gets run within if some split seconds. So that's done now. So then the next step is the reward shaping strategy. So goals of reward shaping is to avoid sparse rewards. Sparse rewards is the reward you get at the end of the whole thing. right? But for reinforcement learning, it's important that you get reward at after every action, right? So reward shaping strategy has goals to avoid sparse rewards and to encourage forward progress, and penalize invalid or inefficient behavior. That's the whole essence of reinforcement learning. So do more of what gives the best results and do less or none of any action that does not give good reward, right? So the shaping techniques. So you have the strategy and their description. You have step penalty. So you have small penalty like minus 0.001 to encourage faster solutions. And you have goal reward like large reward of plus 1.0 upon reaching the goal. And you have invalid move penalty like penalize hitting walls like minus 0.1. Like when you're playing a snake game like that and the snake hits a wall, I mean, that's a kind of loss, right? Then you have distance-based reward, which so here you use change in distance to goal, e.g. A star or Manhattan distance. We've seen a couple of distances like that, like Euclidean distance and all of that. Then sub goal reward, which is optional, right? So that's reward for reaching intermediate checkpoints, like for getting close to the to the goal, right? Some rewards can actually follow. Then the next step is to train the primal policy optimization agent using stable baseline 3. So in that case, if you don't already have it installed, you have to install stable dash baseline 3 extra. So I've already installed it, but I'm just doing this for demonstration purposes. So it is okay now. So it tells me requirement already satisfied. So if you're doing it for the first time, it may take a bit of time. Then this just gets to run. So we have that. So from there, we can go ahead and do the PPO training code. That's the primal policy optimization training code. So again, here you're importing gymnasium as gym. I think that's what I should have done here. Somehow it just works well. Gym was the old version. So the new version is gymnasium. It has been updated. So normally you should have gymnasium. So import gymnasium, then you can still import it as gym, so that works. And then from gym you can import spaces, so that's fine. So so import gymnasium as gym, and from gymnasium import spaces, then import numpy as np. Then from stable, we have the focus is on stable baseline 3 now. So import PPO, import monitor, dummy vector environment, and then you do a what is that called now? Object-oriented programming, Python, and you make a class called maze environment with metadata render modes and human, and then you initialize like this with all these lines of codes. Then you reset, you get observation, you get the steps, and then you render. So that's going to be a very lengthy code. So, but after the first few results, we can start moving on. So here you're using MLP policy if observation is a flattened vector like coordinates. So yeah, this is still running, so it's going to take a bit of time. So I'll wait for it to show a bit of the results. And once that starts, then I keep moving on. And by the time we're done with the video, I'll come back to check how far it would have gone. If it's still on forever, or is this? Oh yeah, this is not showing results. Sorry, I've not got to that point. So we just need. We have trained the PPO. Basically, that's what we have done here. Sorry, and then in step 4 now we have hyperparameter tuning with Optuna. And why do we use Optuna, by the way? It helps to automate search for optimal learning rates, entropy coefficient, etc., and can prune unpromising runs early. Of course, the whole idea of hyperparameter in machine learning is to get the model to work better for sure. So, and then we set the search space, you define PPO parameters trial, and then you return number of steps, gamma, learning rate. Of course, gamma is discount factor, like we've already seen. Then you have the entropy coefficient. So we run this. Now that happens very fast. Then you can tune using CLI or script. And I just come here and run this also. Okay, this is okay. I think this takes a lot of time. Does even okay? Yeah, this is just how to tune using CLI or script, right? That's not what we are not meant to really run that here. That's why it is raw. Then we go here and talk about log training progress with TensorBoard. We are using TensorBoard and Dash, right? And here we set up in PPO now. So here we are defining a maze. So maze is np.array 11111 Of course, where there's zero, that's the terminal point. But where there is one, that's actually an action being taken. So we are setting that maze here. So the maze could be in a CSV file or whatever. But here we are just typing it out this way to be able to just see what happens. And then we wrap environment for stable baseline 3. And then we create and train PPO model. So this is where the actual training of the PPO model is happening, like that, based on the data we have. Then you can now print training complete and model saved as PPO maze.zip. So we can go look for that, after now. Then you can test trained agent and get your observations, environment or reset. Then for dash in range 50, you get the action, the states, and all of these things. So, and if when the goal is reached, it tells us that goal reached or episode ended. So press enter, and then so it says using CPU device. That's that, and then the results start rolling out. So you have EP-learn mean 31.9 and so on. Time steps 2048. This next one, so this one now gives you another rollout 19.6. It just goes on like that. So the time step has doubled to 4096. And then so the tuning has started now. So you have, value loss 0.025 policy gradients, and it keeps going like that. Interestingly, we have come to the end of that. So you have training complete and model saved as PPO underscore maze.zip. So let's go and look for this PPO underscore maze.zip. That should be in the folder we are using for this. Here, PPO, where is that? PPO. Yes, this is it right here. So since it's a zipped file, we can extract it. Yeah, we can extract all. Extract. Yeah, so so you can see all the things we have inside that. We have the baseline, we have the data, we have the policy optimizer and things like that. So let's go back here. So now that that is done, we can view the logs. So if I run this, okay, this is raw too because we can't do that here, right? It's another place. So it's raw just to show you what the logs look like. So you can monitor these scalars now. So for TensorBoard tag and their meaning. So you have rollout. Now the results you can see, you can see all this here, all this EP len mean, EP real mean, and things like that. That's what you have here being explained. So you have the TensorBoard tag and their meaning. So you have rollout EP real mean. That's mean reward per episode. Rollout EP len mean episode length. Train policy loss, policy gradient loss. Train value loss, that's critic loss. And then train entropy loss, that's entropy regularization. So that's what. So that's looking at this result. Now you can interpret some of these things based on those things you have down there. Okay, that's talking about monitoring the scalars. Then we can now build a real-time dashboard with Dash now. So, our goal is to train a model and monitor a PPO agent, that's proximal policy optimization agent, on a custom maze using TensorBoard and Dash. Okay, so build a real-time dashboard with Dash. So here you install Dash and event accumulator. So here, and the first thing is you want to you do pip install Dash to install Dash, and then you have TensorBoard X. So just click on that. It will take a bit of time. I've done it before, so but yeah, I mean you can do it if it's your first time. So now we have Dash installed and TensorBoard X installed. So you have the dashboard structure. So you fetch data from TensorBoard logs, that's event underscore accumulator, and then you update plots in real time with DCC.interval. DCC is dash core components. All right. Yeah. DCC is dash core components coming from dash now. And then dot interval. Then you have graph reward and entropy and then losses. So example code now. Okay, we've installed dash already. So there's no point. Yeah, we installed dash up there. So this is not necessary anymore. So I'll just delete this. So we just do the example code. So from dash import dash, this is the one you saw of the HTML. So from dash dot dependencies import input and output. From TensorBoard backend dot event underscore processing import event accumulator. Then define load rewards. So you're using Python function now. So load rewards log path. Then you define what all of that's gonna do. Then for the app now you have dash double underscore. That's this like you initializing, right? And then you have app.layouts, HTML dive, HTML, H2. I mean, we've done dashboarding right from under data analysis with Python. Then you have the app callback, so reward graph, interval, and all of this. Then update graph also you have this. And so this last two lines is what you use in running the app. So if double underscore underscore name underscore underscore equals main, then app run debug. So I just run this and then so that's so far. So you have the dashboard looking like this. So you have Maze PPO training dashboard. Of course, because I don't have so much data, that's why it's like this. But you can see the callback error updating reward graph figure. So that keeps coming on and on like that. So if I click on this, can we see more things? Okay, you have the error, 5 errors so far. You have the callbacks, you have the server right here active and all that. So this is version 3.0.4 of Dash. So you can see the error logs just keep updating like that with the timestamps like that. So if we have more data, we can have something more robust for sure. So then what we can do next is to evaluate on held out maze layouts. That's another step. So the purpose is to test generalization across unseen maze configurations. So the evaluation metrics will include things like success rate for fraction of episodes where goal is reached, average path length, total steps taken, that may help to know total steps taken to reach the goal, and total reward is cumulative reward in an episode. Time to solve is wall clock time per episode. So we can have this evaluation code. I think this is the one that will take a lot of time that I've been looking forward to. Yeah. So import gym again. Like I said, I mean, you can use gym for now, but in the future, it's already gymnasium and this gym is going to be deprecated. But the interesting thing is that you can still import gymnasium as gym and use that as the alias. So you have import gym from gym, import spaces, import number as NP. Then you have the maze, you have the reset, get observation step, and render. So I think this is where things are going to really get lengthy, I believe. Oh, okay. That's just what it is. Just evaluation. Oh, yeah. Okay. It started. So not found error, trace back, most return caller. So it gives you all these details, all this log information. So directory deleted, TensorBoard PPO has been permanently deleted, right? So you have that there, the evaluation code. So yeah, but then we can go ahead and talk about advanced scaling and experiment management. Okay, so you can speed up experiments. You can use sub-pro vec environment or vec frame stack. That should be vector, I believe, to enable parallel environment execution and improve sample efficiency. Then you can normalize rewards and observations using vector normalize to stabilize training. You can utilize GPU acceleration, especially with larger policies or high dimensional observations for faster model updates. And for curriculum learning, you can begin training on smaller or simpler mazes to allow the agent to learn basic navigation skills. And you can progressively increase maze size, complexity, or introduce dynamic obstacles as the agent improves. And you can design automated curriculum schedules based on performance thresholds. Then you have checkpointing and callbacks. So you can use eval callback or custom callbacks from stable baseline 3 to save best performing models, evaluate agent periodically, and then log additional custom metrics. Then you can save model weight and optimizer states regularly to prevent training loss in case of interruptions. So I mean, yeah, this is what I've been looking forward to. So from stable underscore baseline 3 dot common callbacks, import eval callback. So eval callback now has this eval callback environment, best model save path, and then you have the log. So it's going to be, then you have 10,000. So evaluation frequency is after every 10,000, but then you are going to have like, this is like 1 million time steps. So that's a lot, right? So if you run this, I'm sure this will keep on until the end of this video, and it will still keep on. So it gives the result, it gives the login and things like that. Uh, Right, so you have all the directory permanently deleted all that, and then it gives another set of results and just keeps going like that. Since we have 1 million time steps, so let's leave it to keep doing. Yeah, you can see now I've got to the end, right? I've got to the end of this, but see what's going to happen. Yeah, you have another result now. Yeah, and it just keeps going like that. So in summary, we'll see how far it would have gone by the time we come here. Because let's say, yeah, the time steps here is 16,384, and we're still going to 1 million. 1 million. That's still a far cry. So from here now you have 24,576. Okay, so in summary, you have the component, the tool, and the outputs required. You have the custom environment where you use gym.env, and that is for maze simulation. For the primal policy optimization training, PPO, you use stable dash baseline 3, and that is for trained policy. For hyperparameter tuning, the tool you use is Optuna for best configuration. Then for logging, you use TensorBoard, which is for reward stroke loss metrics. For live dashboard, we use Dash here, which is for real-time training plots. For evaluation, we use custom code, which is for metrics on new mazes. And scaling, we use vectorized environments, GPU and curriculum for faster and smarter learning. So let's see how far the code has gone. We don't have to wait till it ends because it's going very far. Okay, with this night it has gone 59,390. It's not even up to it's not even up to 100,000 yet. It's okay. Okay, there are other results. This is 65,000. Okay. Okay, we have another one now. Interesting. Okay, let's wait for the next one, right? Yeah, this one has gone 70,000 and we are going to 1 minute. Okay, that's okay. It just keeps going like that. So with this, we come to the end of this video, and most likely the end of reinforcement learning, and most likely the end of machine learning. So, and I also feel that have to uh, suspend the playlist for now, right? And I was thinking of going for deep learning, but I doubt it because that's definitely going to make me need some extra compute power, which I may not be able to afford right now. So I was thinking about natural language processing too. I'll see to that, but for now I'm going to leave this and then move on to Microsoft Excel and probably come back to it if possible, right? So it's been a very nice ride talking about machine learning here. With this, I come to the end of this video. And let me know how helpful this has been for you. And if there's something you'd like me to try out, feel free to let me know. If you have not subscribed already, you know you'll be missing out already because there's a lot to learn here, ranging from mathematics to data analysis, now data science, and I'll be going for Microsoft Excel. I think, in fact, the barest minimum for anything data is Microsoft Excel. In fact, there are people that they make all their money using just Microsoft Excel. So they are very extra things you can learn with Excel that are not so common, right? So you want to catch up on all of these things. You want to catch up with these things. So subscribe, hit the notification bell so you can always get alerted each time a new video is released. And of course, you can become a member of my channel. Now, there are 3 levels of membership with different bonus, different perks attached to those levels of membership. You want to check them out and have a nice time for sure. You can download all my code sheets and my data sets so that you can follow along as I do these things. All right, so feel free to like and share also so that more people can have access to this video and other videos like this. Till I come your way again, keep doing data right. Bye. But before the final bye, let's see how far this has gone now. 1 million steps. Let's see how far. Okay. Is it like it's not done, yeah? Oh, 163,840. Okay, it's going. So that's fine. So bye. See you later.